So this one took a while to make. Hello and welcome back to the final installment of Rendering for Design. In today's episode, we're going to be looking at render settings and taking stuff into Photoshop. We're going to work our way up from basic all the way up to less basic. So this is the project from last time. This is the version with just the HDRI. So we've got the dome light there with the texture that we had last time. So if you've made a new project in the last few versions of Cinema 4D, this will already be the default for you. If you haven't and you're working with an older project, then this is one to keep an eye out for. We're just going to run into change render space and set this as ACEScg. You may have to convert your colors if you weren't already using ACEScg. Give it a second, and now our colors are in the ACEScg color space. Now, the long story short about why it's important to use ACEScg and not just sRGB is that you have way more freedom in post. Keeping that theme of editability in post, we're going to jump into render settings, and I'm going to scale this up to be something like 2880 by 1440. You've got other settings here, so you can set your physical size if you are working for, let's say, print. You got millimeters there, and then you can say, actually, I'd rather this be like 300 dpi. And that's not relevant for me today. I'm just working for digital, so I'm going to put it back to 72 ppi, and back to pixels here, 2880 by 1440. This setting here, so frame range, is useful if you're doing an animation. We're looking at just stills in this series, so I'm going to stick with current frame, and we're in frame 5 for whatever reason. But that's that. Next, we're going to head into the Save tab, and if you've got multipass enabled, we're going to disable that for this basic level. And then even at basic, I think you should still have some flexibility in post, so that means switching from PNG into OpenEXR, which will just give you room to have 32-bit lossless floats. And you've also got things like your embedded color spaces and whatever. I think PNG does have lossless floating point values, but OpenEXR just has all the passes, everything in like one file. It's really useful for motion if you want to take stuff into After Effects or whatever. But I find that rather than saving file formats based on what I want to use them for later, it works best for me just to use EXRs all the time. And then I've got the freedom of using them in whichever app I want to use them. So here, EXRs, and then a key setting that I learned from another YouTuber somewhere, I think I go by Zach, is to enable use 16-bit floats. Just helps keeps the file size down so they're not tremendously large, and realistically, the difference between 32-bit floats and 16-bit floats is imperceptible. Next up, we're going to come into Redshift, and we can stick with basic for now. We're going to say bucket quality, and you may want to set this to low, medium, or high depending on your tolerance for noise. I've got a bit of motion blur in this project, so I'm going to actually crank it up to high and then leave it there. We can still turn our combined depth down to about 4 in this, since we're not relying on that many bounces, and transparency I think we can turn down to 0 because there is no transparency in this scene. And that's that. Now all that's left to do is to save this somewhere. So I'm just gonna put this in the Rendering for Design folder. This can be render 1. So we're going to say it's render 1, and we should be good to go. So now all we have to do is hit render. And thanks to the power of movie magic, the render is now complete. So let's go ahead and have a look at what that looks like. I'm just going to go into Show in File Explorer, and we can then open this in Photoshop. So I've got this plugin called EXR-io. I think it's essential if you're working with EXRs. It's free, and I'll put a link for it in the description. Now you can see here the colors look a little bit off compared to how they looked in Cinema 4D. And that's because we haven't told Photoshop that we are using ACEScg. Now the workaround for that right now, because there's no native ACEScg support for Photoshop that I know of, is that we need to assign a profile. Again, I'll put a link in the description to a guide that explains how to do this and where to get the .icc color profile from. So now that that's done, you can see the render that we had set up in Cinema 4D is here in all of its glory. What I'm going to do is start to tweak the lighting a little bit so we can get maybe a bit more depth in the shadows and maybe just bring those highlights down a touch as well. So we've gone from something like that to a bit more of a dramatic look. What you don't want to do is bring these down too much, because that'll start to mess with, you can see there, your whites, which should be blown out. And that's looking good. I'm then gonna combine these, so hit merge layers, and then we can convert that to, I'm never really going to use anything more than 8 bits for now, so merge. Don't do local adaptation, we'll just go with exposure and gamma. Leave those as is because the colors were looking fine on my 8-bit monitor earlier. And now this is an 8-bit Photoshop file. So, that's that. You can do with this what you want, so we can export this as a PNG or as a JPEG or whatever you want. You can do it as an AVIF or a WebP if you're working for the web. So that's entirely up to you how you want to save that in Photoshop. The standard way, if you're just rendering assets, is to do it with the export as, PNG, JPEG, whatever you want. And then all this stuff here, you can include copyright information if you want, up to you. And then hit export, save it somewhere. So that's one way of doing this. Then what I like to do normally is then hit undo so that we still keep our 32-bit, or I guess 16-bit really, file, and then save this as a PSD. So we've got the EXR, which is like the original raw file, if you will, and then this Photoshop file is our kind of compositing or like our edit file. Right now I've only got like a curves edit on there, but you can get more involved with your edits. So keeping this PSD is a really good way of having that non-destructive pathway to change edits or undo edits if you want to do so in the future. So rather than save it as an EXR-io, I'm going to save it as a PSD. We've got 2 dots there. And yeah, just hit save. So now we have a fully editable PSD with all of the original depths. So if you ever do want to then remaster this for HDR and you've got the means, I haven't, but if you do have that, then you've got this PSD to work from, which has all of your edits. So that wraps up the basic version. Now for a bit more of an involved export. There are different ways to do alpha in Cinema 4D, but the kind of bulletproof way that I found is, and it's a bit of a hack actually, is to make the subject that you want to separate from the background, give it an object ID with this Redshift render tag, Redshift object tag. So we give object ID, let's say just 1. And then everything else hasn't got an object ID. So anything you don't want to be part of the foreground, we're going to leave out. And then here, this shell assembly will be, it'll have a Redshift object tag with an object ID of 1. The next thing you want to do is come into Redshift and hit the Redshift AOV Manager. So like I said, this is a bit of a hacky workaround because this option we're going to use, this AOV, is not exactly designed for alpha separation. I mean, it's designed for object separation from what I understand, but we're going to use it for like the most basic level of object separation, which is just alpha layers. So we're going to bring in PuzzleMatte, and you can see here I set red, green, and blue to 1, and we're going to change that to object ID. So scanning the scene by the object IDs and looking for anything with an object ID of 1. For those of you who don't know, AOVs are essentially like extra variables that you can add to your render passes in Cinema 4D, in Redshift, which then get baked into the render file that you export. The cool thing about using EXRs is that those are now just extra layers in your EXR that we can access. So if I now go into our render settings, to access those extra layers, we're going to have to make one small change, which is to change this to a multipass image. And we're still going to say actually make it an EXR, use 16-bit floats. You can save this as a preset, so I've got this saved as EXR 16-bit, and then everything else is the same, multi-layer file, and we're going to then hit render. So we're going to hit overwrite. That should be a new file. Okay, so now that that's rendered, we're going to open up the EXR in Photoshop. And just click OK, these are all good. And you'll see that we have a second layer in Photoshop called PuzzleMatte.rgb. And this is, as we set it up, just a matte of the object, the main subject of the render, because we made R, G, and B all the same in basically black and white. Now it's worth mentioning this isn't a perfect alpha mask, in that some of your background is actually pre-multiplied into the image. However, it is a pretty bulletproof method for separating out your subject from anything else in the background. It works for HDRIs, backdrops, and even things like in-situ renders like we showed in the last video. I tend to use this just because it's so bulletproof and it's like a one-size-fits-all. It'll always work, basically. So the way to get a puzzle matte from this RGB layer is to select the layer, hit copy, paste it in as a channel, then copy the channel, and we're going to come back to our RGB layer and paste it as a layer mask. If we then turn off the PuzzleMatte RGB layer, or even delete it because we are done with it, then you can see that we are left with a transparent background. Now, one thing I've completely forgot to do, and that's totally fine because you can just do it whenever you want, is to change the profile or assign the profile of ACEScg. Do that, we get the color back. Now, one thing to note when you're using this method is you still want to align the color and shade of the background that you rendered with what you expect the background to be in the final use case of this image. If I disable the mask here temporarily and then sample the background layer, oh, there we go. So we're sampling the background. You can see I've got a kind of low mid-tone for the background with a bit of that kind of turquoise color in it. You can watch in the right as the colors sort of jump around. It is a gradient, so it's worth mentioning, like it's going to be really dark over here and it's going to be quite light up here. But generally around the product, which is where that pre-multiplication is happening, you can see that we've got this like low mid-tone of this turquoise color. So whatever background I end up using, if we enable the layer mask again, this effect is going to work best if I align the color to that. And just to demonstrate, if I add a white color, it doesn't look entirely out of place, and the same with like a black. It doesn't look entirely out of place, but these blurs where the opacity is sort of between 0 and 1 are going to look a little bit off unless we match that background color. And now you can see it's a lot more natural looking. If we make it too intense, we're getting, you know, this just the wrong color pre-multiplied with the background. So we bring it to something a bit closer. You can see that this starts to feel a lot more realistic. We can again add something like a curves just to bring those shadows really down into the dramatic depths. The highlights, again, just want to tame them a little bit because they're really, really bright. That's too much, obviously, but something like this. I am a fan of letting the whites just blow out because they should be. And again, maybe it's worth making this background a bit more interesting, so we can add something like a gradient. Go into basics. Maybe we'll add something like a black layer on top, so we can just do something like do backwards, like this perhaps. And I'm gonna add this as an overlay. Oh, that reminds me we're working in 32 bits. Let's take that down to 16-bit. Don't merge. And then we can put it as an overlay. That's really dramatic, so maybe we bring the opacity down a bit. I think that's looking quite good, actually. It's a little bit colorful for my liking. You know, this isn't the real product, but if it were, I still think that the color's a bit rich for a kind of pale blue. So we can bring the vibrance and saturation down a bit. Something like that. Bring the vibrance just for a bit of color separation. And then just keep that saturation in check. This is looking really good, I think. So all that's left now is to hit save, or save as actually. Save it as a Photoshop file. So we're going to say this can be our new background version. Oh, not new 0 background. There. And we can also hit export. I'm just going to hit quick export as PNG, which is basically the same thing as last time. And it will save a PNG in the background. I may actually want to save an 8-bit version of that. So if I do this, set it to 8-bit, and then hit export as PNG, we'll get just a normal 8-bit compatible version of that. One more thing I want to quickly touch on is how to speed up your renders. If you're getting really long render times, stick around because this part's going to be important. I'm just going to jump into the render settings and go into advanced. Let's make the window a bit bigger. And if we go to Redshift, we've got a few options here. The first one, if you're doing any sort of motion work, is to disable random noise pattern. And this just means that the noise is going to be the same in all of your renders. So when you get noise, it's not going to dance around like it would if you, if you hit random noise pattern. As we're in advanced, we no longer have that kind of low, medium, high separation for different thresholds. Instead, we have a slider with numbers that mean something. So you can crank this up, and a higher threshold will mean faster render times, but lower quality. For what it's worth, I think the medium setting is 0.01, the high setting is 0.005, and then we can get lower and lower. This will just take forever though. If you crank your settings down to 0.001, especially with this motion blur, that's just going to take forever. So I'm going to say actually 0.01 is good for us. You can get really granular here. The next one is motion blur. Because we're using that kind of fake camera motion blur, I'm just going to disable this. But if you turn this up, it will take a bit longer to render. So your mileage may vary there. Over here in globals, this is where you can really start to save a lot of time. These numbers essentially define how many bounces Redshift is going to calculate before it says there's no point calculating any more light bounces. You want to have all of these as low as possible. So volume for me will be low because we're not using any volume lighting or scattering. Transparency also set to 0 because there's no transparency in the scene. Things like refraction, again, we can crank down. Reflection, it's worth having some reflection because we are reflecting lights off this model. Now I think we can have that as low as 2 because really we're only having lights reflect off this product and onto the lights or vice versa. There's no kind of indirect scene reflections. If you're doing something with an in situ render, so you have more objects around the subject, then you're going to want to have this reflection setting a bit higher. If you have any transparent objects like glass, then you're going to want to have your transparency and refraction settings set to anything more than 0 as well. Color management, you can see here it's set and it's managed by OpenColor.io. Again, in global illumination, we can crank this trace depth down to 2, and that'll actually save us some render power. And I also like to make the secondary engine brute force as well. We can disable caustics. And so that means that we're not giving any energy to caustics, if anything in our scene is using caustics by chance. And that's essentially it. These are the settings that I would use to save render time. Keep in mind, there is a reason that these numbers are set higher by default. If you have more stuff going on in your scene, you're going to want to have higher numbers, as we discussed earlier. And that about does it, folks. Really quick one today, because there's not much to this. You can go super into the weeds. Render optimization is an entire job in some rendering houses. For our purposes, we can keep it nice and simple, especially if we're not doing motion. I also just want to take a minute to recognize the fact this channel has hit over 500 subscribers. We've hit over 11,000 views across the channel, with over 7,000 of those being on the most recent Rendering for Design tutorial. Despite that being a super long video, all of these numbers are just absolutely mind-boggling to me. So thanks once again to anyone who's shown their support for the channel. I will do my best to upload content that is relevant and exciting going forward. All right, that about does it for this one. Just to recap, we looked at color management with ACEScg and AOVs. We looked at the render settings such as your canvas settings and Redshift basic settings. We then saved that file as a single pass EXR and took that into Photoshop and looked at working with 32-bit EXRs in Photoshop with EXR-io. Next up, we did a slightly more advanced render using a PuzzleMatte as a sort of cheat alpha channel. And it's worth mentioning that this cheat is only really a cheat if you have any values in the alpha channel between 0 and 1. If you've only got 0s and 1s, that is solid background and solid foreground, then there's no difference. We then looked at working with the PuzzleMatte data in Photoshop, and a key consideration if you're using values between 0 and 1 in your PuzzleMatte is to try and preempt the color of eventual use for that background and try and mimic a similar color for the background when rendering. And the final thing we looked at were changing a few settings in Redshift Advanced mode to cut those render times down. Okay, I hope this has been really useful, and I'll catch you in the next one.